All right, so let's look at the next problem here and find an integral of x squared times the square root of 5 plus 2x cubed. So one of these is the derivative of the other, and let's look at it as kind of two pieces. We've got 5 plus 2x cubed here, and then we've got x squared out here. Now, which one could be a derivative? That's the question that we want to ask. And I would say that if we look at 5 plus 2x cubed, and then if we look at the derivative of that, that this is going to be 6x squared. And so what we want to have is we want to have this dx inside of our integral. So we're going to go ahead and multiply both sides by dx. And that's going to end up giving us du equals 6x squared dx. Okay. Now, what kind of integral situation is happening? This is what's happening. I've got a u underneath my radical. So I've got the integral of the square root of u. And then notice that I've got x squared dx, but I have x squared dx. So I need an equality statement for that. And if you'll look where we have du equals 6x squared dx, the 6 can't stay over here. So what I'm going to do is I'm going to divide both sides by 6. And so 1/6 du is equal to x squared dx. Now, this x squared and this dx have an equality statement now with 1/6 du. So times 1/6 times du. And when we work this problem out, what we're going to end up with is the 1/6 can come in front of the integral because it's a constant. U is 1/2 du. Now, add 1 to the exponent, divide by your new number. So I'm going to have 1/6 times u to the 3/2 divided by 3/2 plus c. All right, and there's your integral part. So to finish this guy up, all we would do is we would clean up the fractions. So we're going to have 1/6 times the reciprocal, 2/3 times u to the 3/2 plus c. And lastly is just to reduce this guy all the way down. And this is going to end up being 1/9 u to the 3/2 plus c. So a few more steps in this one because of how our u, when we did our derivative of our u, kind of how it had to go. So there you go. There's that guy. And pause the video or whatever, and we'll do the next one.
All right.